Hello pinball makers, my name is Anthony Van Winkle, and in this video we're going to set up some virtual switches in MPF and control them with GMC to simulate buttons being pressed on a pinball machine, and then we're going to create a carousel in the attract mode to show multiple slides as the attract mode cycles through. Let's jump on in. The original purpose of this video was just to set up the attract slide, but that gets a little complicated because we want to control the attract carousel with flipper buttons. Flippers require switches, switches require a playfield, and a playfield requires a trough with some balls. So first we're going to set up a couple of elements in our hardware for MPF and control them with GMC to simulate flipper buttons being pressed. Let's jump right in. In Visual Studio Code, we've got our project open, and let's open the config.yaml file. Now this is where all of your hardware and machine configurations go. That's not specific to a mode. Now you may already have a config file that's pretty robust if you've got a project and not just following along for the first time, but this is something you may not know. Config files can have sub-config files, which really helps with organization. This main config file could have all of your switches and coils and lights and everything else, but then it's really large and hard to work through. So we're going to create separate config files for some of our components to make it a little bit easier to work with. And we'll start right here by going Control-N to make a new file. And we'll start with the standard MPF config, #config_version equals 6. This is required at the top of every MPF config file. And we're going to save this file in our config folder, already there, as config_switches.yaml. Now note, the save as type is plain text, but in my Windows I have file extensions turned on, so I always know what extension I'm using. If you have file extensions hidden, you may end up with .yaml.txt, so watch out for that and just turn on your file extensions to make sure. So we'll save this, and up here we see config_switches.yaml, which is exactly what we want. And now we can define our switches. So we'll make a switches section with a colon, and then go and indent in. Now, config files can have comments, so we'll use a hashtag to make a comment here to say we're going to define our cabinet switches. And the convention with MPF is all switches start with an S underscore. That's helpful if you have something like a kickback that might have a switch and a coil and a light. The switch is S underscore kickback, the coil is C underscore kickback, and the light is L underscore kickback. So they can all be associated through the name kickback, but you know when you're referring to the switch, the coil, or the light. So our flipper will be S underscore flipper underscore left, colon. Now every switch requires a number. When you're setting up your hardware, you may have an address on your Fast or your Cobra or whatever platform you're using, and that would go right here. We're not connecting this project to hardware right yet, so we'll leave the number blank. And we will also add a tag, and that is going to be left underscore flipper. Now this is a special MPF tag that tells MPF that this is a flipper, so behavior like cycling, auto-fire, and flipper cradles can be automatically hooked up through MPF by giving it this tag. And we'll define the right flipper with S flipper right, indent, again empty number, and the tags right flipper. Now, because MPF has dependencies, switches require a playfield, playfields require a trough, and troughs require switches to identify how many balls are there, we're going to go ahead and identify some trough switches as well. So we'll leave a comment to say trough switches, and we'll just put in a couple here. S trough 1, no number, S trough 2, and S trough 3. Now you may have more if your trough is bigger, but just put in whatever trough switches you need. You may have a jam switch, anything like that. We're also going to assume that we're using a standard pinball setup where we have a trough that all the balls drain into, and those trough balls are kicked into the plunger lane where the user can manually plunge the ball from the plunger lane into the playfield. So we'll add a switch for our plunger lane as well, S underscore plunger underscore lane. Just like that. So we can save this file, and this switches section here we want to import into the main config file. And that we can do in the config file with another section called config. So we'll keep it alphabetical, so above the modes we'll add config, and this is a list of names. And this will be config_switches.yaml. It is important to have the extension here. But now with config switches, when we load this main config file, it will pull in that config switches section and the switches definition in it. So the switches require a playfield because MPF uses the playfield to understand where the switches are and where the balls are. So we need to define a playfield, and we'll do that with the playfields section. You may have multiple playfields in your game. If you've got a mini playfield or something underneath the main playfield or a two-player head-to-head game, most games just have one playfield, and the convention is to call it playfield. So this is the name of the playfield, which happens to be playfield. And we're going to define a couple of properties. First, we're going to define the source device. So when this playfield needs a ball, either because there's a ball save or a multi-ball or some other reason, when it needs a ball, it needs to know where that ball comes from. And that's called the default source device. And this is going to be a ball device, which is our trough. Just like switches, coils, and lights, ball devices are prefixed with BD by convention. So BD trough. And tags, this is going to be tagged as default. So if we don't specify a playfield, this is the one we're going to use. And that's because you may have switches on your mini playfield or on your under playfield that will be specifically designated as such, so that if MPF detects one of those switches, it knows the ball is on the mini playfield. So default means that we don't have to specify a switch is on this playfield, it just assumes that it is. So we can save that. So we've said BD trough is our ball device, so we better define that. And we're going to do that in another config file called config ball devices. So Control N for new file, hashtag config version equals 6, and we're going to save this file as config_ball_devices.yaml. And here we can add ball devices. So the first one we need is our trough, of course. That's BD_trough. And the trough that we're going to set up here, yours may vary, but this one we're going to have a switch for every position in the trough, so it can count how many switches are active and know how many balls are there. So we'll use the ball switches setup, and we'll list our 3 switches, S trough 1, S trough 2, and S trough 3. You may have more. The eject coil, this is how a ball gets out of the trough. So if the playfield says, hey, I need a ball, it will fire this coil to get the ball out. Eject coil, and this is a coil, so we'll start with C_trough eject. The eject target is actually eject targets, plural. So this is where MPF's ball management comes into play, because the ball device can go from one ball device to another ball device. The playfield is a type of ball device as well. But since we're using a plunger lane, when a ball is ejected from the trough, it doesn't go straight to the playfield, it goes to the plunger. So we want to tell MPF that when we kick out a ball to the ball from the trough, look for the plunger to make sure the ball arrived, and then we'll go from the plunger to the playfield. That way the ball can sit, the player can plunge when they want to, and we're not waiting for switches on the playfield when the ball's not there. So the eject target is going to be BD_plunger. And we have some tags to add here as well. That's going to be trough, comma, home, comma, drain. So what does this mean? Trough means that this is the default place where balls live. You can have other places where balls live, such as a lock, a Newton ball, or some sort of preset scoop that has a ball in it at all times. But the trough is sort of the main home, so we define that there. Home means that this is an okay place for a ball to be when the game starts. If you have a ball lock that's not home, MPF will eject the balls out of that lock and get them to a home device before it allows a game to start. But again, if you have a static ball or a captive ball somewhere, a home is good for that. And drain means that if a ball comes in here, a ball has drained from play. Now, older pinfields or older pinball games may have had a separate drain that would then kick into the trough. You may have that set up, but modern games, typically the balls just go right into the trough. So the drain tag means that if a ball suddenly appears here, assume that the ball has drained, and if it's the only ball in play, the turn is over. Okay, so we've got the BD plunger as our eject target, so we'll need to define that as a ball device. And this one is going to have ball switches, just one switch of the S plunger lane. And we're going to give it mechanical eject, true. So mechanical eject means there's a way for a player to mechanically get the ball out of that device, such as with the plunger shooter rod. And this means that MPF is not going to try to fire a coil, and it's not going to time out the ball waiting here, because it's up to the player to mechanically eject that. Now here we don't need to specify eject targets because Playfield is the default, so when we say no eject targets, it's going to assume that the ball is going to eject from this ball device into the playfield. So we can save that, and back in our config, we will add config ball devices.yaml here. So we're almost done, but there's one more thing we added. In our config switches in our ball devices for the trough, we added the C trough eject as an eject coil, which means we need to define what that coil is. So we're going to once again make a new file and config version equals 6, and we're going to save this as config_coils.yaml. And here we're going to define our coils section. And for now, we only have one, which is the trough eject. And it needs a number. Again, we can leave this blank for now, or if you're hardware setup, you can use that. Now, there are a lot of things that we can specify about coils, like how long they fire for, how strong they fire for, when we determine if the eject is successful or not. But for now, we're just going to save it as that. In our main config, we're going to import alphabetically config coils.yaml. And that's everything we need on the MPF side. But we've set up a lot of hardware here, and a lot of these have interdependencies, so it's a good thing to check and make sure everything works. So we'll pull up our friend PowerShell. We will activate our environment. And then we will go to our project folder. And now we're going to run MPF. We're going to run it in virtual mode, so -X. We're going to run it with the command terminal, T, and we're not going to connect to a media controller, so B. And everything loaded, starting the main run loop. That means that the config files all passed and everything that was dependent resolved correctly. So we are good to go. The next thing we want to do is simulate switch hits by the keyboard using GMC. So that's done in the GMC config file, which we'll open up here. We already have our sound system configuration that we did in a previous video, and now we're going to add a new section called keyboard. So open up a bracket and type keyboard. And here we can define different keys that we press and behaviors that they'll do. Typically, a behavior would be either triggering a switch or triggering an event. I like to use the comma and the period for my flippers because they're next to each other, so you can use one hand to toggle them back and forth. And they also have the caret icons up above, which is a very good visual reminder, left flipper, right flipper. You may use something else if you wish, but we're going to use the comma and period in this example. So we'll say comma, and then we open a curly bracket with the list, or sorry, a straight bracket with the list. And this is going to be a switch, and that switch is going to be S flipper left. And then do period as a switch, and S flipper right. Now there are advanced options here where you can use a button to set a switch to on, set a switch to off, toggle the state of a switch, or other things. But we're not defining that here, which means that when the key is pressed, the switch will go active, and when the key is released, the switch will go inactive. So pressing the key is effectively the same as hitting the button. And that's all we need from the configuration side. So let's go into Godot and set up some slides. An MPF carousel is a special type of mode that MPF has that allows a list of items to be available and cycled through based on events or switch hits. The attract mode is inherently a carousel, so all we have to do with the attract mode is set up what we want the carousel to have. So we'll open the attract config, and at the top we'll put a section called mode settings. Attract is already a carousel, so these mode settings are the carousel settings. And first we'll have selectable items. This is the list of things that are in the carousel. And for this example, we'll have a title screen with the name of the game. We'll have a credits screen with free play or the number of credits or how many coins are required. And just for fun, we'll have an MPF logo to show that we're proud MPF users. We will have next item events. And this is what says to the carousel to select the next item in the list. And we're going to use S flipper right active. So if the player presses the right flipper button, it moves to the next item. And our previous item events, S flipper left active. So the left flipper goes the other way. And We'll set up a timer and we'll do some other fancy stuff in a minute, but for now, let's just see how that works in Godot. So we will save this file and open up the Godot editor. We'll open up our project. And here we are on the attract slide. Now, when I made this before, I just put this text right in a random place, but we want all of our carousel items to be the same. So we're going to go ahead and expand this up so it's vertically and horizontally centered, just so everything can be in the same place. Okay. So GMC comes with a lot of helpful classes that make things with MPF work a little bit easier, and it includes a carousel class. So we're going to add a new node here, and we're going to search for MPFCarousel. And we're going to add the carousel node to the screen. Now here's something very important, and this is where a lot of first-time users get confused or get carousels that don't work. In the inspector panel, there's a carousel name, and this is the name of the mode that MPF is running the carousel from. Because remember, carousel is not an MPF device, it's not something you configure in the YAML, it is a mode itself. So you may have multiple modes, you may have multiple carousels, you may have multiple screens, some of which are doing one or the other. So we need to put the name of the mode whose carousel we're controlling here, and that is attract. Otherwise, it won't work. So the way the carousel node is set up is that it will have multiple children, and each children will be the name of one of the selectable items. So this here, Welcome to Happy Pinball, that is essentially our title. So we can just drag that node into the MPF carousel as a child, and there it is. Now the names have to match. So if we look back at our code, the selectable item, the name is title. So this child we will name title, all lowercase. And that means that when this title is the selected item in the carousel, this child will be visible, all the other children will be hidden. So we're going to add another one now for the credit string. Now this is going to come from machine variable, because MPF stores a machine variable that either says free play or 1 credits, 2 credits, however many credits are in the machine. So we're going to add a new child, and this is going to be MPF variable. Now if you notice, Godot by default made this one a child of the previously selected one with just title, and we don't want that. So we're going to drag this to be a sibling of the title, both first level children of the carousel. It doesn't matter the order they're in because it's the name that makes the difference. And if we look back at our selectable items, this one is named credits. So we're going to name this child credits. And we're going to configure the variable. The variable type is a machine variable, and the variable name is credits_string. It is a string, so we don't want a comma separate or anything like that. However, there's no value there now, so it's a little hard to see what's going. So we're going to put in some sample text just so we can make sure everything looks right. And we will drag this up like that. We will set the horizontal alignment center, vertical alignment center, and we will set the theme overrides font size to 80 to match the other one. And we will drag it down so they're in the same place. Now it overlaps a little here. If you want to see what you're doing a little bit more clearly, you can use the eye icon here to show and hide layers, but it doesn't matter what it looks like here because when the carousel initiates with MPF, it will take care of that. And the last thing we want is the MPF logo, and that's just so we have an image in here so you can see how that works. So we're going to add another node, and this is going to be a sprite 2D, which is another way of saying picture. So again, it did it as a child of the credit, so we're going to drag it up. And this one is called MPF_logo. To attach an image, you go over to the inspector under Texture, under Empty, and you can go to the Load option, which will give you the full folder tree, and you can navigate through, or you can do Quick Load, where Godot will identify the types of files that are appropriate for this and give you one to choose from. If you've already got your own image in your folder, pick that. Otherwise, we can use the logo MPF.PNG from the GMC project. And we'll undo that. We will select the logo and move it over into the center. And save. And that's all it takes to set up the carousel. So we can play the project in Godot and open up our PowerShell. And here we're going to run MPF-XT, but not going to include the B because we do want to connect. So MPF boots up, and we can see here we are. And now, right now the carousel doesn't have any auto rotation, but if we press the period button, it moves on to the next one, and we can use the comma to go back. And you see that here it says free play. Even though in the Godot project we put the text sample text, it's reading the machine variable of free play to indicate that. And if you switch your game to credits, it will change accordingly. The next thing we want to do is add a timer so that the attract carousel will automatically rotate every couple of seconds. And we'll do that using an MPF timer. In our attract mode, we will set a section called timers, and we'll have one called attract carousel timer. A nice, easy name. Now, typically with a timer, you would change the number of ticks to get from start to end, so you can have an event at every tick for updating a timer on screen or setting a hurry-up value or something like that. In this situation, we don't care anything that happens between the start and the end of the timer, so rather than filling our logs with events and posting every second, we're just going to have the timer do a tick every 5 seconds. So timers go up by default, so they start at 0. So we'll set our end value of 1 and our tick interval of 5 seconds. We want this to start running, so start running is true. And we want to be able to control this with a couple of events. So the first thing we want to do is every time a new item is highlighted, we want to restart this timer. And that's going to be -event item highlighted. That's a carousel event built in. And action restart. Note that the event has a dash in front of it to show it's a list item, and the action is aligned with the indent of the event. So you may say, well, we could just have the timer automatically restart every time. Why not do that? Well, yes, that's true, and that would give the expected behavior, except if the player is manually cycling through items, that timer is going to keep running. So they may end on something they want to see just before the timer expires, and then it moves over. So by using the item highlighted to restart the timer, every time a new slide comes up, it will wait a new 5 seconds before automatically rotating. Another thing we want to do is allow the player to hold the carousel on a screen for an indefinite amount of time. This is helpful if you want to get a selfie of your score, or if you're in a tournament and you want to record the scores. So we're going to allow the flippers to be held so that the carousel will not rotate for as long as the flipper is held. So we'll set up another event, and that's flipper cradle. Now this is a built-in MPF event where if one of the flippers, one of those switches tagged as flipper, is held for 3 seconds, the flipper cradle event is automatically posted. And when it's released, the flipper cradle released event. So we'll use the flipper cradle event to give the action stop and event flipper cradle release of the action restart. That way the player can hold the flipper down when they select something and it will stay there as long as they want, and the timer will continue after they release it. And in order to have the timer actually rotate the carousel, we need to go back up to our carousel and next item events. We're going to do a comma and add another event, timer underscore attract carousel timer complete. We're using the complete event rather than the stopped event because, again, with highlighting and flipper cradling and things like that, it may stop and start a lot, but complete means it successfully gets to the end of its tick interval. So we will save that and start the project and see how it goes. So here we are at the main slide, and if we do nothing and just wait after 5 seconds, it will automatically rotate to the next one. And after another 5 seconds, it will automatically rotate to our third one. We can also use the flippers to scroll through as we like. And if we hold the flipper down, then it will stay here as long as we want. I'm not going to talk for a super long time, but we can look in the logs and see that the timer has stopped. And then when we release, the timer will resume. You can look here, you can see flipper cradle event, stopping timer, flipper cradle release, starting timer. So that means everything's working exactly as it should, and we'll never have an annoying carousel cycle when we don't want it. If you're just following through these videos with your own little tutorial project, you probably haven't played a game yet. But if you're incorporating this into your existing project, you may have some games played, and you may want to show the scores of previous games on the attract carousel. So that's what we'll set up here. The selectable items on the carousel include support for conditional items. So we're going to add a new item here called last scores. Now typically on a pinball game you'll have a different layout depending how many scores there are. If it's 1 score it might be nice and big, or 2 or 3 or 4, however you want to lay them out. So we're going to create separate versions of slides in the carousel that will show the appropriate layout and sizing depending on how many players there were. So this is going to be last scores for a one-player game, and we're going to use a curly brace to open a condition. And we say we only want this to show if there is a one-player score in the game's history and not a two-player score. So we'll say machine.player1_score and not machine.player2_score. Let me move this out of the way so you have a little bit more room. So what this means is if there's not a player 1 score, like you've never played a game or the machine has never scored a game or you've cleared all the variables, this is not going to show up. But it will show up if there is a player 1 score and not a player 2 score. What if there's a player 2 score? Well, we're going to do last scores 2-player. And this will be machine.player2 and not machine.player3 score. We'll assume that we can go up to 4 players. So the 3-player will be the same, machine.player3 and not machine.player4 And the last one will be last scores 4-player, machine.player4 We don't need any other conditionals on that because these are dependent on each other. There will never be a player 4 score without a player 3 and a player 2 and a player 1. So this is enough. So MPF will only post one of these events ever because they are mutually exclusive from our conditions here, and it will only post one of them if there is a score to show. So we can save that and go back to Godot, and we'll need to add children to our carousel to handle how that works. So a single player slide, that's fine. We can do just any sort of text label that we want. But when there's going to be multiple children, multiple pieces of text, we're going to want to contain that into a single child so they all show or hide as part of the carousel. So we're going to make a new node on the carousel, and this is going to be node 2D, which is just the generic, nothing special, nothing in particular. We're going to add a node 2D, and we're going to call it last scores 1-player. And we're going to add an MPF variable. And this variable is what we're going to call player1. Now the name of the variable here, that's just for our own record keeping, so it's easier to see what's going on, but we do need to configure this as a variable. So in the inspector, variable type machine var, variable name player1_score. Now this is a number, so we want to comma separate it. It's unlikely that somebody would have a score that's less than 100, but just to be safe, we'll have 2 minimum digits. And in order to see what it looks like, we'll put in some numbers here. And just like the other one, we're going to want to make this full size. We're going to make it center, and then down in the theme overrides, font sizes, 80 pixels. So that's our player 1 score. A 2-player game, we're just going to copy this node. So we're going to right-click, duplicate, and we'll rename this one to be 2-player. It's getting a little crowded here, so let's turn off some of these things that we don't need. Okay, so there's the player 1 score. But since this is a 2-player game, we want them to be, out of the way of each other. So we're going to take this player 1 score and move it up there. We're going to duplicate the node and name this player 2 score. And in the inspector, we're going to change the machine variable from player 1 score to player 2 score. And we're going to take that player 2 score and drag it down like this. And save. So this machine currently doesn't have any high scores on it or any previous game scores on it. So when we play the project and run MPF, there's actually not going to be any difference. It's going to load up the carousel, and the carousel is still just going to have these 3 screens because there are no previous scores. So what I've done is I've set up a machine variables file that now includes a previous score for player 1, just to demonstrate how this will look. So we'll run MPF and start the game. And now in our attract carousel, you will see that there is a score there. It is in the right place based on the selectable items before the MPF logo and after the credit string, and it's using our single large piece of text. And now I've added a second player score to the history, and we can run MPF again. No changes to the code, no changes to Godot. But when the slide loads up, we'll see that it's using the 2-player slide instead of the 1-player slide. And there it is, 2 scores. So the carousel is choosing the slide based on the name, and the name is coming from MPF, which is using those conditions to determine which item is highlighted. So you may now want to go through and add your scores for 3-player and 4-player games, as well as anything else you might like in the carousel. And that sums up this video. We've got an attract carousel slide running, it's got conditional events, it's showing machine variables, and in the next video we'll actually start a base mode, start showing player scores, ball numbers, and other things from multiplayer games and single-player games. So stay tuned, thanks for watching, and happy flipping.